Case 4. Case 4 of a spherical triangle. It is a right angled spherical triangle. Obviously, by the name, it is a right angled spherical triangle, means one of the angle of the triangle should be 90 degree. You can see the diagram here. In the diagram, you will observe the angle capital B is of a 90 degree. Angle capital B is of a 90 degree. So it is a right angled spherical triangle. To solve the problems on a right angled spherical triangle, step number 1, you should draw the Napier circle. So to draw a Napier circle, this is a rough sketch only. Draw a rough circle. Okay, draw the rough circle. Divide this circle into the 5 parts. So you can divide this circle into 5 parts by 2 different ways. Just draw one cross here, and then you can draw this vertical line, or you can draw this circle and you draw this horizontal line. Then here is one vertical line, and then you can, so just divide the circle into the 5 sectors, and these 5 sectors not necessary of equal area. Once we get that Napier circle, we can give the number to these sectors. So sector 1, 2, 3, 4 and 5. So you can start giving number from anywhere. So I started 1, 2 from here. If you are not happy, you can start 1, 2, 3, 4 and 5 also, that way. But in general we started from this sector only, but okay, you can start giving numbering from any of the sector. So once you give the numbering from 1 to 5 to each sector, the first rule for the Napier's circle is part 1 and 2 are replaced by the sides, adjacent sides of a 90 degree. So here is a capital B is of a 90 degree. So adjacent sides of this 90 degree are small a and c. So here I replace a and c. Okay, so I replace small a in 1. So if you want, you can replace small a in 2 also, and this small c in 1. But 1 and 2, the part 1 and 2 should be replaced. Part 1 and 2 should be replaced by the adjacent sides of the 90 degree triangle there. 90 degree. Then this part 3 is a complement of the angle of the side A. Complement of the angle of a side A. So because 3 is opposite of 1, 3 is opposite of a sector 3 is opposite of sector 1. So it is a 90 minus capital A. Similarly, 5 is opposite of a 2. So this is a complement of the angle of a small c, that is a 90 minus capital C. So same thing is here for 1. For 1, 4 is opposite, is it? So it is a 90 minus capital C, and here is a 90 minus capital A. Lastly, this part 4 is replaced by part 4. This is my mistake. Actually, here is a 90 minus C should be there. So you will observe here is that this 3 is the opposite of C. So this is 90 minus capital C. This part 4 is only left, and that is the complement of the hypotenuse. The complement of hypotenuse is a 90 minus small b, and that's a part 4, 90 minus small b. So here is the way of completing the Napier circle. Now our Napier circle is ready, and this Napier circle can be used for the Napier's rule to get the answers. So let I quickly show you this Napier's circle and to fill up these rules. So here is the first thing that we have to draw a circle. First we'll draw the circle. We divide the circle into the 5 equal parts. Okay, 5 parts mainly. Once we divide these 5 parts, we give this number from 1 to 5 here. Then part 3 is a complement of the 1. We already discussed about this. Okay, and here is our Napier circle now. Can you see the circle? So here this Napier circle, now we are going to use it in the Napier's rule. So now move to the step 2 here. The step 2, there are 2 rules that we have. The first rule is here, sine of the middle part is equal to product of the cosines of opposite part. Sine of middle is equal to product of the cosines of opposite part. Now we can consider any of the part as the middle part. Let us assume, say, let me assume here this part 2 is a middle part. Okay, this part 2 is a middle part. So tell me first, or which should be the opposite part with respect to this part 2. Okay, so with respect to this part 2, this part 5 and part 4 are the opposite parts there. Okay, they are opposite parts. So we can have sine of this middle part A is equal to cos of cos of yes 90 minus A into cos of 90 minus B. Correct. So this way we can use this rule. But remember, any one of these part can be considered as a middle part. So with respect to this rule, we can create a five formulae we can create with respect to this rule. Okay. Now there is one more rule, one more Nappier's rule here, and this Napier rule is sine of the middle part is product of tangent of adjacent part. So remember this tangent adjacent. So these are rhyme words, they go together. Tangents and adjacent go together, while cos and opposite go together. Cos and opposite go together. So that is one more Napier rule that we have. Now, with respect to this rule also, we can create 5 more formulas. So total we have 10 formulas with Napier's rule. Out of that, just we have to select one formula to get the required component, to find the required component there. Okay. One more thing you will observe that in Napier's rule we again come across this sine function, and this sine function creates the ambiguity. We already know this, because when we take sine inverse theta or sine inverse of x, we get theta or 1 minus 180 minus theta, is it 180 minus theta, and we have to select the correct angle. And here, to solve this ambiguity, instead of that rule, greater side should have the greater angle opposite to it. Instead of that rule, we use same affection criteria. What is the same affection criteria? In a right angle triangle, mainly, whenever angle, say this angle C, suppose it is acute angle. If this is acute angle, then side C should be acute. This also should be acute. Acute means less than 90 degree. Suppose capital A is obtuse. Capital A is obtuse, then small a should be obtuse there. Okay. So this is the same affection criteria. Means if angle is less than 90 degree, opposite side should be less than 90. Okay, that way. So that is our same affection criteria here. So, and lastly, this is the same affection criteria, you should remember. But last thing is here, that every time we come across this sine, cos or tan with 90 minus theta. So you should know these 3 formulas, and that 3 formulas are sine 90 minus theta is a cos theta, cos 90 minus theta is a sine theta, tan 90 minus theta is cot theta. Remember, all these things are positive. Why they are positive? Because 90 minus theta is the angle in the first quadrant. 90 minus theta is angle in the first quadrant. So in first quadrant, all trigonometric functions are positive there. So sine 90 minus theta is cos theta, cos 90 minus theta is sine theta, tan 90 minus theta is also cos theta. That's what. Any doubt here? Will explain about entire methodology, importance of what is no. So we'll move to the examples here. So you'll see the question is on the screen. In a spherical triangle, that PZX, it is a right angled at Z. So important thing, we are given this triangle is a right angled triangle there. So as it is a right angle triangle, step number 1 comes, we have to draw a Napier circle, because this problem can be solved by a Napier circle there. So first we'll draw a rough sketch. The rough sketch I will show you here. The rough sketch is like this. So draw one triangle, show that capital Z is a 90 degree. Capital Z is 90 degree. These sides are given, so we can mention their values. And we have to find out this capital X, we have to find out small p, and we have to find out small x. So we'll draw a circle. We'll draw a Napier circle. So draw a rough circle. Divide this circle into the 5 parts. Give the numbering to this circle. Give the numbering to this circle. 1, 2, 3, 4, and 5. Now, this part 1 and 2. Yes, part 1 and 2 are replaced by the adjacent sides. Adjacent sides means this small x and small p. Small x and small p. These are the adjacent sides of the 90 degree. Okay, I will write it with some other color. This is a small x, this is a small p. Next, we have then, yes, part 3 should be 90 minus angle. This is 90 minus angle, capital P. And lastly, complement of hypotenuse is a 90 minus small z. Now, yes, to get the missing components, before we should know which sectors values are known to us. So let I tick mark these values. So a few of the values we already know. So we are given a small p. Small p is here. So this is known to us. Small z is known to us. Sector 2, sector 4 is known, and capital Z is nowhere in the sector. So only these two things are known, and remaining 3 quantities are missing. Say small x, capital P, capital X. Okay, so this is the capital P. This one is a capital P there. That's what. These are missing. Now we have to select one of the sector as a middle part, and we can use the Napier's rule. So if you want this sector 3 as a middle part, sector 3 as a middle part, so we can take sine of 3 is equal to tan of adjacent, because sine of middle part is equal to tan of adjacent. So the first one we can use sine of 90 minus x is equal to this, just a minute, tan of adjacent, so tan of p into tan of 90 minus z. Now remember this this p is known, so tan p can be calculated on calculator. Tan 90 minus z means cot 90 minus cot z. Okay, you can calculate cot of z with a calculator. Just multiply. Sin 90 minus theta become cos x, cos of capital X, and x become a cos inverse. So we can compute capital X. We can compute a capital X with this first formula. Okay. Now move to the second. Now yet we have to find out two missing components, small x and capital P. To get a small x, yes, to take this as a middle part. So for this middle part, you will observe 3 and 4 are opposite part. So you can take sine of x, sine of small x is equal to cos of 90 minus capital X into cos of 90 minus small z. Now this cos 90 minus capital X becomes sine of capital X, and this becomes sine of small z. So we get sin x value, but remember sin x creates the ambiguity, and to solve that ambiguity we should use the same affection criteria there. So by this formula we can get a small x. And lastly, third, to get the value of a capital P, again there are multiple ways you can do it, because to find out phi, you can use one of the 10 formulas. So we already know that 2 rules. With that 2 rules we get a 10 formulas. You can use any one of that formula from that 10. Not anyone, but majority of the where that sector phi is used. So that formula is useful. Say sine of phi sine of 5 is equal to tan of 1 and 4, or sine of 5 is equal to cos of these two, or sine of 4 is equal to cos of these two. Sorry, the sine of 4 is equal to tan of 5 and 3. Okay, that way. Use any one and you will get that required answer. So let me see a solution step by step here. So here is the Napier circle. For this Napier circle, the first rule that you can see is the formula sine of middle part is equal to cos product of cos of opposite. So sine of 90 minus z is cos of these two. Okay, cos of opposites, that this one, small p and small x. And you will observe you get a cos inverse. Cos inverse of this number is 106 degree 54.4 minute there. Now to get a this capital P, sine of middle part is equal to cos of opposites. Similar formula, same formula only. But you will observe the most important thing, when you take a sine inverse of this, you get theta, and pi minus theta, that two angles there. And here you get two angles, 70 degree and 109 degree. So which should be the correct answer? So to solve this ambiguity, to get the capital P value, just focus on a small p. Small p is a obtuse angle. Small p is a greater than 90. So capital P should be greater than 90, because the angle and opposite side should be of same affection. So if side is obtuse, angle should be obtuse. So by same affection criteria, capital P should be 109 degree 31.3 minute, and that should be the answer there. Okay, and here you have that final answer there. That's the final answer. And exactly similar way we can get that last missing component. Here we calculated a small x, capital P, and now the only thing that is missing is that small x is calculated, capital P is capital X. Now only capital X. So for capital X, this one we can use any of the remaining rule, and here is the final answer. Sine of middle part is the product of a tan of adjacent, and final answer is 105 degree 54.5 minute.